Alright, so here we are at chapter 10. This is actually, we're talking about roots and radicals. We'll just talk about roots and radicals. This is UW Whitewater Aufmann text. Chapter 10 talks about roots and radicals, but in general we're talking about roots and radicals. And we're going to talk about a couple different things. Definition of a square root and maybe an nth root. Nth root is kind of a little bit just one more step beyond, but if we talk about the square root, we can generalize to the nth root as well. So in general, what is a square root? A square root, excuse me, sorry. Square root talks about this. What number, when squared, equals 25? And that would be the same thing as square root of 25. And we talk about the square root because in here there's an unwritten number. And we assume that if it's not written, we assume that there's a 2 in there. So the square root, one written 2, means we've got the square root of 25, asking the same question. What number, when squared, gives me 25? Well, we know that 5 times 5 is 25, so it's got to be 5, right? Oh, wait a second. How about negative 5? You know what? Negative 5 could also be negative 5 times negative 5 could also be 25. So which one is it? Well, this square root symbol always asks for the positive square root. So it's true that negative 5 times negative 5 is 25. So this could be, but you know what? Just to make sure that we all know what that square root is looking for, we always assume that it's a positive number, that the positive number is what this square root is looking for. So anytime we see the square root of 25, well, it's true that negative 5 times negative 5 is 25, but that always equals 5 because we're always looking for the positive square root. So we always look for the positive square root when we're looking for that symbol, when we see that symbol. If we look for a negative number, well, we can have just, put a negative sign out in front of it, and we get the negative square root. Square root of 0 is also 0, so 0 times 0 is 0. So let's take a look at simplifying some general square roots. Square root of 36. All right, well, we know that 6 times 6 is 36. Square root of 225. 15 times 15 is 225. We're always looking for that positive square root. Square root of 1, 1. Square root of 9 fourths, 3 halves, because 3 halves times 3 halves gives us 9 fourths. 9 fourths is what's inside that square root. Outside the square root is 3 halves. Square root of 9 fourths is 3 halves. And there we go, just some general rules about square roots. Keep in mind, too, that square roots are approximations. Unless you've got a perfect square that says something like square root of 4, well, 4 is a perfect square, so we can always say that's 2, then that's equal to 2. But if we take a look at something like square root of 2, what's the square root of 2? Well, if you pull out the calculator, it's going to be, say, 1.4, and then, oh, there's a 1 behind it, 1.414, dot, 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 and over there, this dot, dot, dot goes on to infinity and beyond, because that, we can't say that 1.4 is square root of 2, or square root of 2 is 1.4, or square root of 2 is 1.41, or square root of 2 is 1.414. We can't say that because this goes on to infinity and beyond. So if we're looking for the perfect number, the exact number, it's square root of 2. Keep in mind also that there's no real square root of a negative number, because take a look at this. Square root of a negative 1 is, well, gosh, could it be 1? 1 times 1 would give me 1. That doesn't match what's inside there. So 1, throw that away. How about negative 1? Negative 1 times negative 1 should give me what's inside here. Negative 1 times negative 1 is 1, but it's a negative times a negative, gives me a positive, and that doesn't work either. So officially that's defined as I, just the imaginary number I. I is the square root of a negative 1. So there's an entirely new system of numbers that's out there that's out beyond the real numbers. So if we generalize, like I said, we can also generalize to an nth root. We usually talk about square roots, and that unwritten number in here is a square root. But if we talk about the nth root, like a cube root, for example, a third root would be a cube root of x, or let's say a cube root of 8. What number is that? Well, I'm looking for the number that when multiplied by itself 3 times gives me 8. Oh, it's got to be 2. 2 times 2 times 2, that's 3 of those 2's together. 2 times 2 times 2 is 4, times 2 is 8, sure enough. Cube root of 8 is a number that when cubed gives me 8. So there's that, and then in general we're just talking about nth roots. Nth roots means that nth root, that n, could be here. We're talking about third roots or fourth roots or fifth roots or sixth roots, and that's why we in general talk about nth roots. is that. But we're not going to talk about nth roots too much. We're going to talk mostly about square roots. This is pretty mathy, so we're just going to move on. All right. A lot of times we're going to simplify. And in fact, later on, we're going to find that we can simplify square roots. Smart doesn't do a good job with square roots, so I have to kind of put the roof over the square root. We'll talk about the square root house as well, but square root of 100 is just 10, because 10 squared gives me 100. All right, sounds good. 10, and a lot of times we're going to look for those perfect squares inside of here. This one, 100 is a perfect square. 4 is a perfect square because square root of 4 is 2. It's a perfect number that comes out. Perfect number that comes out of the square root of 100 is 10. And that's an exact number, so that's a perfect square. That's a perfect square. 100 is a perfect square. 4 is a perfect square. So let's take a look at some of these. Cube root of 8, we did that one before. That's 2. 2 times 2 times 2. 2 cubed is 8. Fourth root of 16, 2, because 2 to the fourth power is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16, and that gives us that number that we're looking for. Fifth root of 32 is also 2. So 2 to the fifth power gives me 32. Sounds great. And we can just kind of keep going with all these, but you know what? We get the idea of what we're trying to do with simplifying expressions. We're trying to get what's inside that square root house outside. And if we can find a perfect number, a number that's exact here, then that's a perfect cube. 16 is a perfect fourth power because 2 to the fourth power, an even number here or a whole number here, to the fourth power gives me 16. So there's a couple different things. Now we're going to rewrite. We're going to find that a lot of times, in fact, in the future, we're going to rewrite something like this. We can rewrite cube root of 8 is 2. I'm going to rewrite this as, instead of writing 8, we're going to write 2 to the third power. So now the third root of a perfect cube, this is a perfect cube in here, 8 is a perfect cube, we can rewrite it as 2 to the third power, means that the base gets to come outside the house. That 2 gets to come outside the house because it's a perfect, this 8 is a perfect cube. It can be rewritten as a perfect cube, 2 cubed. Cube root of a perfect cube means the base comes outside the house. So that's why we can rewrite all these. Cube root of 8 as that. Fourth root of 16 is fourth root of 2 to the fourth power. Fourth root of a perfect fourth means the base comes outside the house. Fifth root of 32, fifth root of 32 means that's fifth root of 2 to the fifth power. Fifth root of a perfect fifth means the base comes outside the house. And we can use this whole idea when we work with squares. And if we work with square roots, we can actually kind of rewrite this square root of 10 then. Square root of 100. Square root of 100 is square root of 10 squared. Square root of a perfect square means the base comes outside the house, which we know square root of 100 is 10, but if we rewrite it as a perfect square, that means that that base gets to come outside the house when we take the square root of it, and we're going to use that a lot later on. Alright, this one is just some more examples, so we're going to move on to that one, this page here, in the next video.